Hello again, and welcome to episode 2 of A Pint of Astrobiology, the show where I discuss the latest conundrums in the field of astrobiology over a pint of beer. My name is Ben Pierce. I am an astrobiologist, an amateur brewer of beer, and your humble host. And today I'm drinking a homebrewed double IPA. It is very bitter. And also 7.9% alcohol. So let's get into this before I start to slur my words. Today's episode addresses the question of how and where life began on early Earth, with a focus on the two main hypotheses researched by scientists. Number one is the warm little pond hypothesis, and the other is the hydrothermal vent hypothesis. Or you can think of these as the surface hypothesis and the ocean floor hypothesis. Now the picture on my left is a photo that I took at Lassen Volcanic National Park in California of a hot spring. And the photo on my right is a picture of carbonate-like chimney structures found at Lost City in the Atlantic Ocean, which vent out hot alkaline fluid. Now, both of these places are thought to potentially be ground zero for the origin of life 4 billion years ago, as they meet a few of the basic requirements. Things such as they both have liquid water, they have energy sources, they have potential ways to form biomolecules, and also potential ways to concentrate those biomolecules. So, how close are we as a community to determining which of these two hypotheses is correct? Not that close, actually. The problem is for anything to be proven in science, it needs to be demonstrated repetitively with experiments, or you need to be able to observe it occurring elsewhere in the solar system, or maybe someday beyond. And both of these hypotheses, vents and ponds, have undemonstrated parts to the ways in which they would form life. So no one can say for certain yet. The thing that makes hydrothermal vents so appealing is that there is ongoing geochemistry occurring at the ocean floor, which resembles the chemistry of cells. For example, the naturally occurring proton and pH gradients that occur at the interface between the vent and the ocean water resemble the proton and pH gradients occurring across the mitochondrial membrane in cells. So, is this just a coincidence? So, some scientists take this as a hint that primitive cells survived in these naturally occurring proton and pH gradients until they evolved the ability to maintain their own proton and pH gradients and thus became self-sustaining life. But science deals in evidence, and presently there's no demonstration of this geochemistry leading to any kind of chemistry of cells. There has been a lot of theory work done to narrow down the primitive metabolisms that could emerge in these environments, but theory on its own isn't enough. Now, full disclosure, I do research on the alternative hypothesis, but I'm going to attempt to give a equally balanced critique of the warm little pond hypothesis. So here we go. The reason that the pond hypothesis is so appealing is that it has been demonstrated in the lab that you can form long strands of RNA by simulating the wet and dry conditions that are naturally occurring in warm little ponds. RNA, similar to its sister molecule DNA, is a critical molecule of life. RNA can both store information and copy that information, making it potentially the first self-replicating life form on our planet. But there are problems with this hypothesis too. For example, it has not been demonstrated in a lab that you can produce the entire building blocks of RNA in early Earth conditions. But scientists have gotten partially there. They have demonstrated the production of nucleobases, which is the rungs in the picture of RNA that I put up here. Furthermore, it has not been demonstrated in the lab that you can have a fully self-replicating RNA molecule. But again, scientists have gotten partially there. They have demonstrated that a certain RNA molecule can take chunks of itself in the environment and bond them together to form itself or to copy itself. All in all, there's still a lot of lab work to be done to prove that life can emerge in either of these environments. Now, I personally think that the pond hypothesis is a tad further in proving its plausibility. However, if one day a big discovery is made in favor of the hydrothermal vent hypothesis, I will be happy to reassess and adjust my research endeavors accordingly. After all, we scientists are just here in search of the truth. So that's all for today. Cheers.